Hi everyone, welcome to Multiplying Integers. We're dealing with multiplying positives and negatives here, and there's really only two things you have to remember about multiplying positives and negatives. But be careful, you don't want to confuse these with adding and subtracting positives and negatives. Remember your soup, remember the balloon, remember the other stuff that we learned about adding and subtracting positives and negatives. But don't get it confused with this. So the rule is simple. If you multiply two numbers, not 3, not 5, not 7, but two numbers with the same sign, you will come up with a positive. So that's like 2 times 2, they're both positive. The answer is, of course, 4. If I took negative 2 times negative 2, since both of these are negative, a negative times a negative would equal a positive. Now with the different sign, two numbers with a different sign. So like if I had negative 2 times, we'll just say 3. Since this first term is a negative, this first term, or the factor, this first factor is a positive, that means they have different signs. Your answer is negative 6. Or if I had, let's say, positive 4 times negative 5. They both have different signs. The first factor is positive, the second factor is negative, so your answer is a negative. It is as simple as that for the rules. You just can't confuse them with adding and subtracting. So what we're trying to learn today is why these rules are what they are. So I'm looking at today's handout. It's multiplying rational numbers. It says Georgia Department of Education at the top. And what we're doing is we're modeling multiplication of positives and negatives. So some things to understand. Running to the left or west means negative. And time in the past is also negative. Running to the right or east means running in a positive direction, so your number is positive. And time in the future is positive. So we've got Jonas here. Here's Jonas. He's running 5 meters per second to his right. So he's going right. Where is he 10 seconds later? So we can think about this as every second he covers 5 meters. So here's 1 second, 2 seconds, 3, 4 seconds, 5 seconds, 6, 7, 8, 9. In 10 seconds he covers 50 meters. So our number sentence would be 5 times 10 equals 50. So if he's running to the right, in 10 seconds from now in the future, so that's positive, he would be 50 meters away. Scrolling down to problem 2, Dwayne ran 5 meters per second to the right. So he's moving to his right. Where was he 5 seconds ago? So this is a little bit different. We have to look at this as if he has been running already, and now here he is. He has been, in the past, running 5 meters per second to the right. So where was he 5 seconds ago? So we'd actually have to think of this as the past. So if he was going 5 meters per second, if I went back here to say negative, I don't know, 50, in 5 seconds from negative 50, he'd be at 1, 2, 3, 4, 5. He'd be at negative 25, so that can't be right. 5 seconds ago, he was at negative 25 because it's 5, 10, 15, 20, 25. That was his position 5 seconds ago. The way we write the number sentence is, since he was moving right, that's positive. But since we wanted to know where he was in the past, that's 5 times negative 5. So our answer is negative 25. We'll do the third one while we're here. Ariel runs west at 4 meters per second, so she's going that way. Where will she be 10 seconds from now? So in every second she covers 4 meters. So after 1 second she's just before this 5. After 2 seconds she's at 8. After 3 seconds, she's at 12. 4 seconds, she's at 16. 5 seconds, she's at 20. So I can write this as, since she's going west, left, she's running a negative. And since she's in the future, it's a positive. 4 times 10 was negative 40. Now in the next, not the next page, yeah, actually it's the next page. It'll help you to know that the way we're finding these is taking the rate, so how fast the person's going, multiplying it by the time, and that gives us, this should be an equal sign, that gives us their position. On the number line. So I'm going to correct that. So if we're given the rate, like 4 meters per second, left or right, and we're given the amount of time, then we're multiplying them together to find where that person is on the number line. In this case, it was negative 40. In another problem on the next page, you'll be given 2 of these, and you put in a variable for the one that is missing. Okay, last thing that I'll cover on this video is the 4th page of your handout. And it's just 2 ways of understanding why a negative times a negative equals a positive. Now you can watch that video on the website. It'll help it stick in your head. But a negative times a negative equals a positive. Question is why? One way of understanding this is this sequence. It's negative 6 times numbers that go down by 1 each time. So 3, 2, 1, 0, negative 1, negative 2, negative 3. So you can see that negative 6 times 3 is negative 18. Negative 6 times 2 is negative 12. Negative 6 times 1 is negative 6. Negative 6 times 0 is 0. Each time we're adding 6. So negative 18 plus 6, negative 12. Negative 18 plus 6, negative 6 plus 6. If we keep on adding 6, we start getting into positives. We keep that sequence going. So the sequence is one way to justify that a negative times a negative equals a positive, because math follows patterns. So there's the pattern. There's another way, and that has to do with our chips. So I'll get rid of this stuff. Now, negative 2 times 3. We're saying that's negative 6 based on a rule. But why? Well, first let's think of this as repeated addition. If we had 2 times 3, here's another problem. 2 times 3. That would, as repeated addition, it could be 2 plus 2 plus 2. We just add 2 together 3 times, or add 3 groups of 2. Just because this is negative, this first factor is negative, it doesn't change the concept. All we're doing is we're adding 3 groups of negative 2 this time. So it would be negative 2 plus negative 2 plus negative 2. And you know how to add integers. You've got 2 negatives, you add 2 more, that means you got 4 negatives, you add 2 more, you got 6 negatives. In our soup model, what we'd be doing is we'd be adding in 1, 2, there's a group of 2, add in another group of 2, and another group of 2 to have 6 total negatives. So that's all there is to it. It's nothing like complicated. It's just like what we've always been doing with this soup, except it's repeatedly adding groups of negative 2. And that's all. Okay, the last set of problems here. Understanding why a negative times a negative equals a positive. We just said negative 2 times 3 would be negative 6 because we had 3 groups. We were repeatedly adding 3 groups of negative 2. So now we've got to understand this as a subtraction problem. You'll be repeatedly subtracting groups of negative 2. So you'll start at 0 And instead of adding this time, you're going to be subtracting, 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 because that's a negative. So we'll be subtracting -2 and subtracting another -2, subtracting another -2. Well, as I'm sure you recall, subtracting a negative, that's the same as adding 2. So we'd be adding 2, adding 2, adding 2. What we're doing is subtracting 3 groups of -2. To model it, you've got to remember back when we were using that soup, you've got to remember 0 pairs. If we wanted to get some soup into our soup, if we wanted to get these cold chips, we're trying to subtract these cold chips, we need to get them into the soup first. So we bring them in as 0 pairs. And then we can take out, now that they're in the soup, we can take out the colds and be left with the hots, the +2. It's the same thing by modeling it here. You've got to bring in 3 groups of 2 0 pairs. So 1, 2, 3, 4, 5, 6. And to bring those in, I need to grab their opposites. So now that they are into my soup, I can subtract 3 -2s. Subtract 3 groups of -2. So 1, 2, 3. And I'm left with +6. Okay, last thing. Practice problems. Very simple. 6 times 4, what is it? 24. Are they different signs? Yes, positive, negative. So that's a negative. Easy, easy, easy. So let's see, negative times a negative. 2 times 1 is 2, but since they are the same sign, they're both negative, our answer is positive. Okay? Very easy. Only place you might get caught up is when you have 3 factors here. So let's take a look at number 18. I've got -6 times -10 times -8. You might be thinking, well, a negative times a negative times a negative must be a positive. Not the case, because we've got to multiply these together step by step. Well, what's a negative times a negative? A positive. So -6 times -10 would give me +60. But now I'm multiplying that +60 by -8. So now I've got a positive times a negative. So my answer would be, since they're different signs, -480. So the idea is that these two negatives, you multiply them together, they'll cancel each other out. Just be careful of that, and you will do just fine.